So after looking at how we expand a bunch of logarithms, what we want to look at next is how we would combine logarithms. And this tool is going to be useful for us for solving equations in later sections of this chapter. So just before we get started, something that's going to come up a little bit in some of these questions is taking a number, like a simplified number, and actually writing that inside of a logarithm. So I just want to go over that before we actually get into some of the questions. Just so you sort of have it as its own thing. So yeah, we want to express 3 as a base 5 logarithm. So essentially what we're trying to do here is write 3 equals log base 5 of something. And so the goal is to find out what this is. And so we could just let that be an x. So 3 is log base 5 of x. And then to solve this equation, we could rewrite it in the exponential form or use our power of equation solving of trying to cancel that log base 5. And we cancel it with a base 5 exponential. And so we do the same thing to both sides. On the left, we get that cancellation. And so that tells me that x is 5 to the 3. Right? That also goes hand in hand with our rules of cancellation. Right? We know this statement to be true. This is one of those basic rules at the start of this section. So this is always true. And so to put this in the base 5 logarithm, it should be, no matter how you slice it, 3 is log base 5 of 125. So this is something that we're going to need to be able to do here to answer some of these questions. It will definitely come up. Yeah, because what we're going to want to do is take like everything that's written and wrap it into one little logarithm ball. And sometimes some of those things are like floating 3s or floating 2s. So this is how we do that part of it. Okay, so here we've just got a bunch of examples of sort of long simplified logarithms, and what we're going to want to do with these is just combine them into one single nice logarithm. Well, I guess one single messy logarithm actually. So we're just going to basically go back and revert all the rules. So yeah, I'm going to rewrite the rules again. Yeah, so I just jotted down the 3 rules up in the corner that we mostly focus on. So for the most part, yeah, we need to kind of revert everything that we had done before. So combining is, I guess really it tends to follow your order of operations more than anything. So for example, if you look at rules 1 and 2, like you might be looking at A and seeing that there's addition between the 2 things. But if you look at rule 1, you'll notice that the added things are just simple, like just logs. They don't have numbers out front of them. So in order to add them, we have to get rid of the numbers out front first, which means we have to deal with the multiplication first. So that's going to be stage 1, is dealing with that multiplication using rule 3. So these guys are going to actually go back inside as powers on the 2 expressions there. And so I'm going to have log base 3 of x squared plus log base 3 of y5. And now I get to go ahead and use my rule 1 with the addition. And combine that as multiplication. And that should be my final answer. So for the next one, first of all, same idea. I'm going to deal with rule 1 first. Always deal with those multipliers first. And so what I'm going to get is log 2, and a to the power of half is just root a. So I'm going to jump right into that. Minus log 2 of b cubed plus log 2 of c. There's nothing on that one. And then minus log 2 of d to the 4. And then what I'm going to do is use something I talked about in the other video, and that is the fact that these additive terms are going to go on the top, And the the negative terms, the ones that get subtracted, go on the bottom. So instead of breaking this into a whole bunch of ugly steps, I'm just going to do this in one big go. And so what I'm going to have is my one big logarithm, and then on the top, I'll get my root A times C, and then on the bottom, B cubed D4. So just save self a little bit of time there. You could do it in two steps, like you could do the first pair and make a quotient out of that, and then do the second pair and make a quotient out of that, but you'll find that you should get the same result here. So finally, C, this is what I was talking about at the start of the video. We need to put this 5 into a base 3 logarithm. So what we can do is write 5 equals log base 3, and then so that should be 3 to the power of 5. So the idea being that cancellation on the right would leave us with exactly 5, but I don't want the cancellation. I want it actually in that base 3 logarithm. So that is actually going to be log base 3. 3 to the 5 is, I think it's 243. Yeah. So that tells me how to do that. So I can actually rewrite this as log base 3 of 243 plus, I'm just going to go ahead and put that 3 into the exponent for the x there. So that'll be x cubed. And now I can just combine with the first rule. So I'll get log base 3 of 243x cubed, like this. All right, finally, D, if you've noticed it, this is actually a trick. So what we've got here is log base 3 of x plus log base 3 of 5. The bases are different, and there's not really any coherent rule for combining these. So I can't do this. So that was a trick. There you go. Yeah, so I think this is about it for difficulty. What usually creates problems with students is what happened in example C there. Yeah, you have to force it into a logarithm. If I say put it in one logarithm, it includes the 5. So it's again, it is something that you want to be able to do for solving equations. So it is worthwhile.